Today we are going to learn about efficiently merging large data frames with Pandas. We'll explore techniques that enable you to handle large datasets efficiently by optimizing performance without compromising speed or memory. In the world of data science, merging large data frames efficiently is a crucial skill. It allows us to work with massive datasets without sacrificing speed or memory efficiency. Today, we'll delve into techniques using Pandas to perform these merges effectively. We'll cover challenges faced when merging big datasets, explore the Pandas merge function, and provide strategies for optimizing performance. By the end of this video, you'll have the tools to enhance your data-driven applications, ensuring they run smoothly even with large data volumes.
Merging large datasets can pose significant challenges, primarily due to the sheer volume of data involved. This can lead to memory constraints, where the available RAM is insufficient to handle the data, resulting in slow processing times or even crashes. Additionally, inconsistencies in data formats or key fields can complicate the merge process, necessitating careful data cleaning and preparation. Efficient algorithms are crucial in overcoming these hurdles, ensuring that merges are performed swiftly and accurately. In this segment, we'll explore these challenges in detail, setting the stage for strategies to address them effectively. The Pandas library provides a robust merge function, which is fundamental for combining data frames. This function supports various types of joins, such as inner, outer, left, and right, allowing for flexible data integration. Key parameters include how, which specifies the type of join, and on, which determines the key columns for merging. Understanding these options is critical for performing merges that align with your specific data requirements. We'll also discuss how to handle missing data during merges, ensuring that the resulting data frame maintains data integrity and completeness.
Indexes play a pivotal role in optimizing the merging process. By aligning data frames on their indexes, merges can be significantly faster, especially when dealing with large datasets. Setting an index that uniquely identifies rows before merging can reduce the complexity of the operation. Additionally, index-based merges help in maintaining data consistency and can simplify the code. In this section, we'll demonstrate how to set and reset indexes for optimal merging performance and share best practices to ensure that your merges are both efficient and reliable.
Memory optimization is crucial when merging large data frames. One effective strategy is to optimize data types, for instance, converting float64 to float32 where precision loss is acceptable. This can reduce memory usage substantially. Additionally, ensuring that only necessary columns are involved in the merge avoids unnecessary data duplication. Tools like Memory_Profiler can be used to monitor and manage memory usage. For extremely large datasets, processing data in chunks can prevent memory overload, allowing merges to be completed efficiently without requiring excessive computational resources.
Multi-core processing can drastically enhance the speed of merging operations by distributing tasks across multiple CPU cores. Using libraries like Dask, which extends Pandas functionalities for parallel computing, can lead to significant performance improvements. This is particularly beneficial when working with large datasets, as it allows for scalable and efficient data processing. In this section, we'll explore how to implement multi-core processing in your data frame merges, providing you with practical examples and demonstrating the potential speed and scalability benefits.
Duplicate keys can complicate the merging process, leading to unexpected results or data inconsistencies. It's essential to identify and manage these duplicates effectively. Strategies include using the indicator parameter in Pandas to provide a flag indicating the source of each row. This helps in diagnosing and resolving key conflicts. Additionally, it's crucial to understand the implications of duplicates on the final dataset and to implement measures that preserve data integrity. We'll delve into real-world scenarios where duplicate keys are prevalent and demonstrate effective management techniques.
In this case study, we'll examine a practical example of merging large financial datasets. We'll discuss the challenges faced, such as heterogeneous data sources and varying data structures. Solutions implemented include optimizing data types, using efficient indexing, and leveraging multi-core processing. Performance outcomes showed significant improvements in both speed and memory usage, enabling seamless integration of large financial datasets. This case study not only highlights the practical applications of the techniques discussed but also provides valuable insights and lessons learned for handling similar challenges in your projects.
Beyond Pandas, several tools and libraries are available to enhance merging performance. Dask, for instance, is used for parallel computing and can handle larger-than-memory datasets efficiently. Dask is another library known for its speed in handling large datasets by leveraging lazy evaluation and out-of-core processing. We'll compare the performance of these tools with Pandas, examining their integration capabilities and potential use cases. Understanding the strengths and limitations of each tool will help you choose the right solution to meet your specific data merging requirements.
Adopting best practices is essential for efficient data frame merging. Start with thorough data cleaning to ensure consistency and accuracy. Select the appropriate type of join based on your data analysis objectives. Implement effective indexing strategies to enhance performance, and manage memory usage by optimizing data types and processing data in chunks. Continuous learning and staying updated with the latest tools and techniques are crucial in the ever-evolving field of data science. By following these best practices, you'll be well equipped to handle large data merges with confidence and efficiency. In conclusion, mastering the art of merging large data frames with Pandas is a vital skill in data science. We've covered key strategies, including optimizing memory usage, leveraging multi-core processing, and handling duplicates, to enhance merge performance. The skills acquired will empower you to tackle large datasets with confidence, ensuring your data-driven applications are both efficient and effective. As you continue your learning journey, we encourage you to explore advanced techniques and tools, applying the knowledge gained to real-world challenges. Thank you for joining us in this educational journey.